Hi everyone. Today we're going to continue on to 2.4, solving multi-step equations and inequalities. So it's important to note when variables are on each side, to solve an equation with the same variable on each side, first use the addition or subtraction property of equality to write an equivalent equation that has the variable on just one side. So when I look at example 1, I notice that I have a 5y on the left and a 3y on the right. I need to get those on the same side. It really truly doesn't matter which one I move. I tend to move the smallest one. So I'm going to do the opposite of 3y, which is subtract 3y from both sides. And I can only subtract like terms. So 5y minus 3y, those are like terms. So that's 2y minus 8 equals 12. And now I have my best friend a two-step equation. The opposite of minus 8 is add 8. And then I have 2y equals 20. The opposite of multiplying by 2 is to divide by 2. Y equals 10. And then it's also important to note that when I'm checking an equation with two variables on each side, I always start out by writing the original equation in my check, and then I substitute. And once I substitute, I treat each side of the equation independently. And what I'm trying to see is if they do in fact equal. So this is 50 minus 8, which is 42. That's the left side. Then the right side, I have 30 plus 12, which equals 42. So it does indeed check. When I'm solving an equation or an inequality, 3a minus 15 is greater than 4 plus 5a, I do the same method. Now here, it's more important, not more important, but it makes the problem easier if you move the smaller one. That way I don't have negatives, because when I divide both sides by a negative, I need to flip the inequality. And by moving the smaller, I can tend to avoid that. So I first need to solve this. So I'm going to subtract the 3a from both sides. And that gives me negative 15 is greater than 4 plus 2a, because 5a minus 3a is 2a. I subtract 4. Yet negative 19 is greater than 2a. Divide by 2. And negative 9.5 is greater than a. Then it says to graph it on a number line. So negative 9.5. I always put my answer in the middle and then work left and right. Negative 10, negative 10.5. It's an empty circle on negative 9.5 because it's only greater than. But a is less than negative 9.5 if I read that. So a goes this way. And then using interval notation, that goes from negative infinity to negative 9.5. And they're both parentheses because it's not equal to, and infinity always gets a parenthesis. So I would like you to pause, and I would like you to solve 1 through 8, come back and check, and then we'll go over the rest. Okay, here are the answers. Number 1 is x equals 2. 2 is negative 4 equals r. 3 is t is less than or equal to 45. 4 is 7 is greater than or equal to u. 5 is b equals 5, 6. 6 is a equals negative 6. 7 is t is less than negative 8. And 8 is t is less than or equal to r. If you have any questions on those, please note them. So now we're going to start some word problems. Number 9 we're going to do together, and then I'm going to leave you to do a couple and come back and check. Tripling the greater of two consecutive even integers gives the same result as subtracting 10 from the lesser even integer. What are the integers? So when I read this problem, first of all, I take note that I'm talking about two consecutive even integers. So I let x equal a consecutive even integer. And then remember we talked about that if x is my first number, to get to the next even, I need to add 2. So x plus 2 is the second even integer. So now that I've defined my variables, I go back and I read. Tripling the greater. So the greater one is the x plus 2. So tripling that means 3 parentheses x plus 2 gives, that's another way of saying equals, the same result as subtracting 10 from the lesser. So the lesser integer is x, and I'm subtracting 10. So I subtract 10. So my equation is 3 parentheses x plus 2 equals x minus 10. So now I solve. So that's 3x plus 6 equals x minus 10. I'm going to subtract x from both sides, and I have 2x plus 6 equals negative 10. I'm going to subtract 6, and I get 2x equals negative 16. Divide by 2, x equals negative 8. So my consecutive even integers are negative 8 and negative 6. So now I want you to pause and I want you to try the next 5 and come back and check your answers. Okay, so for our word problems, we did number 9 together. Number 10, I'm going to let x equal the number of sessions. My equation is 3/4 x plus 3 is greater than or equal to 12 because she wants at least 12. So at least 12, we're going to do greater than or equal. I solve that and I get x is greater than or equal to 12. So she needs 12 or more sessions. 11, I'm going to let x equal a number. My equation is x is less than 1/4 parentheses 3x plus 4. I need those parentheses because it's 1/4 the sum. So I solve that and I get x is less than 4. Write it in interval notation and it's negative infinity to 4. And 4 is in parentheses, sorry, Kimmy. And I graph it. 12, let x equal a number. My equation is 2 parentheses x plus 4 is less than or equal to 3 parentheses x plus 7 minus 4. I solve and I get negative 9 is less than or equal to x. 13, x is my first consecutive even integer, x plus 2 is my second. So my equation is x equals 10 plus 1/2 parentheses x plus 2. Solve and I get x equals 22. So the consecutive even integers are 22 and 24. 14, let x equal the consecutive even integer, x plus 2 equals the second. My equation is x plus 2 equals 3x minus 6. Solve, x equals 4, and therefore the consecutive even integers are 4 and 6. Last but not least, my let statement is x equals the first positive integer, x plus 1 the second, x plus 2 is the third, and x plus 3 is the fourth. I then set the fourth one, x plus 3 is equal to 2x, and my answers are, the numbers are 3, 4, 5, and 6. Please note any questions you want me to go over tomorrow in class, and have a great night.